Good morning, all. Thank you for being here. My name is Praveen Amancharla. I'm the CTO at Quisk. Over the last 2 years or so, Quisk engineering team has been hard at work building a world-class global payments platform and a new payments type. And naturally, we ran into a lot of challenges. We were able to overcome some of those challenges with innovative, creative solutions. Some of them we really worked hard and learned it the very hard way. So my hope and my goal for the next 15 minutes or so is to share some of those learnings with you. So if you are a startup out there trying to pitch for banks and trying to build solutions for banks, hopefully there are some takeaways. And conversely, if you have encountered the same problems and solved it in a better or different way, I would really love to listen and learn from you. All right, so before we get into the details, I just want to spend a few minutes, not a whole lot, on explaining what the business problem we are trying to solve so you can appreciate why we did what we did. Quisk has built a cloud platform for banks, and banks use our platform to issue a new type of bank account to customers. So think of you have your checking account, you have your savings account, and then a customer would have a Quisk account. Except the Quisk account can be used with just a mobile phone number and PIN. So consumers can do in-store purchases, P2P, pay to street vendors, bill pay, all those things without needing cards or physical cash or even mobile apps. And why is it important, right? So if you think of developing countries, especially cash-rich or cash-intense economies, 90% of transactions still happen in cash, and it's a pain for customers and merchants. So our belief is that Quisk offers a simple digital alternative to physical cash and helping customers, merchants, and banks. So I have a short demo to illustrate what I just verbalized right now. If you could please project the screen here. Let me demonstrate a simple in-store purchase. So think of this, this device as a merchant point of sale terminal. This could very well be a Verifone or Ingenico terminal. What we did is we also built a MPOS app to help merchants adopt the Quisk as a payment type faster. So I opened the MPOS app. So of course, I'm going to play both the roles of a customer and a merchant. So customer walks into the door. They want to buy something for $1.50. Merchant would click on sale, enter the amount $1.50, submit, and would hand over the device to the customer. The consumer would type the phone number and PIN. Remember, that was what I said in terms of the credentials that consumers use to pay with Quisk. Use the phone number and PIN, and act of entering PIN is very much similar to how you would enter your debit card PIN. And you would say pay. Payment is successful, and the consumer would get an in-app notification if they have a mobile app, or SMS if they have a feature phone. And the consumer can just log on to their app using phone number and PIN or a Touch ID alternatively. They can see the transactions and a whole bunch of other use cases. I'm not going to go through all these. That kind of illustrates like an in-store purchase. We also have our APIs that third-party merchants have integrated, e-commerce merchants and mobile merchants. So one example of m-commerce is a merchant in Jamaica has added Quisk as a payment type on their gaming application. So I'll open this third-party app. Let's say I'm a customer who wants to bet something on this online poker. I pay, I select the money I want to place a bet on. And then, again, now this window pops up. Customer can type in the phone number or PIN or pay using Touch ID. And the bet gets accepted, and the customer gets an in-app notification. Again, don't want to get into too many details in terms of business or go-to-market, that kind of stuff. More than happy to discuss those at the booth if you're interested. So what have we learned while building all this stuff, right? Again, I'm going to keep this at a relatively high level. If you have some deep questions, technical questions, my partner and I are more than happy to discuss at the booth. I believe the neatest and coolest thing that we did in our platform, in our technology, is to satisfy a diverse, broad spectrum of requirements. We consider ourselves as a B2B2C kind of company. So we build products that end consumers use, payment products that end consumers use, but we go to market via banks. So we use banks as channels to drive our products to the customers. So there's a consumer play and a merchant play. On the consumer side, we made our payments as easy to somebody on the streets of San Francisco using the latest iPhone 6s as to somebody in sub-Saharan Africa with a $1 Nokia feature phone. Right? That's the broadest spectrum of customers we satisfy, and everything in between, a whole bunch of Android users, people who are more comfortable with a web and a browser, and so on. Likewise, on the enterprise side, what we do is something very analogous to what Visa does. So we partner with issuers to bring in customers, we partner with acquirers to bring in merchants, and we create this payment network. So to me, the number one thing when I think of innovation in fintech is this ability to deliver these innovative products to mass markets, at the same time playing nice with the existing established ecosystems, because you don't want to, I mean, it's very hard to change the status quo in terms of the existing ecosystem, but you still have the ability to drive these innovative products. So as we started building services, like any other technology company, we stood up well-defined, secure APIs. One thing that we quickly realized is it's just not sufficient to develop APIs, document them, and maybe have some examples. That's not enough. What we felt and what we experienced was it is relatively easy to get the attention of a marketing department from a bank as opposed to the IT department. So instead of waiting for the IT department to, for example, integrate Quisk as a payment type or a Quisk account into existing mobile apps, we went ahead and created white-labeled standalone solutions for our banks, right? What it also helped us do is to eat our own dog food. So the white-labeled apps that we built don't go through any backdoors. They go through the public APIs that we share with our partners. So by the time the bank's IT department would be ready to integrate with us, we give them all these applications as a reference implementation, and thereby reducing the time it takes for them to build the application. So based on my experience, my recommendation would be, don't fear or don't feel shy from white-labeling solutions to seed it, to get the adoption going. Of course, it's not a long-term solution, but it's a very good stopgap measure. And we have a slightly different variation of APIs, which we call as public APIs, for lack of a better word. What we mean by public APIs is those requests that we get directly from third-party merchants, whether it's an e-commerce merchant or the example that I just showed in the demo, a m-commerce merchant, where a third-party merchant introduces your payment type into their existing flows. Think of a pizza ordering app that would add Quisk as a payment type. Since those requests are not being routed through the partners, our paramount concern is protecting the user credentials. So a consumer would use their phone number and PIN. We wanted to make sure that the phone number and PIN would never traverse through the third-party merchant application or through the third-party merchant backend. So how did we solve this? We did two things. Number one, we came up with a concept called as, again, a virtual terminal. What we mean by that is, if you remember the demo that I showed, as soon as a consumer, I go to this third-party site and I say I want to pay with Quisk, it opened a window, a login PIN window. That code was delivered by Quisk. So we call it as a login package. In the mobile world, what we do is we create this package, we compile it, we obfuscate it, give it to the third-party developers. What it does is when the consumer is ready to pay by Quisk, it challenges the user for username and PIN. The request goes to the Quisk platform, and a token is generated. The equivalent in the e-commerce world is we have a simple JavaScript where a consumer would say, I want to now pay with Quisk. That would open a JavaScript window asking for consumer's username and PIN, and the request would securely go to Quisk, where a token is given to the merchant. Subsequent request, the merchant can use token. And we don't write the code to generate token because you can only go so far in terms of security. So what we do is we use a third-party crypto library to generate a token and also create a unique salt with it for a token and a lifespan on the token. This two-step process where we separate out the act of authentication and act of payment using a token, it gave our merchants a lot of flexibility in terms of how they want to intersperse Quisk requests into their workflow. Had we put it together, the act of collecting the username and PIN and the act of making payment would be all in one, and some of the merchants wanted more flexibility, different ways of putting Quisk into their workflows, and thereby we were able to achieve that flexibility, give merchants the flexibility. So I strongly recommend use of token-based authentication. Make sure it is short-lived. Continuing on the topic of PIN security, from get-go, we knew that PIN is the most sacred piece of information we have. And we always wanted to hash it. We didn't want to go through encryption or any of those things. What really helped us is one-way hashing and definitely using salt. What we do is we, again, use a third-party crypto libraries to create a unique salt per user, per PIN. So consumers can change their PIN at any point of time they want. They forget PINs, they want to change PINs. Any point of time, a PIN is changed. And this can be applied to passwords too. PIN is just equivalent to password. So anytime a consumer's PIN is changed, we generate a new salt. It's a unique salt, randomly generated salt, and we store salt and the digest of the PIN in separate databases. Again, you could very easily go wrong with hashing because there are multiple nuances there. For example, we have a 10,000 iterations. On one end, you want it to be more complex, so you prevent brute force attacks. You can increase the iteration count. But on the other hand, the more tight you make, the more the delay would be perceptible to your consumers as they try to log in. So it's kind of a fine balance. You would want to try a couple of things and make sure whatever works optimal for the form factor that you want your users to get authenticated. And the biggest recommendation I have is no matter how high you scored in your algorithm scores, don't write your own crypto. There are plenty of solid crypto libraries out there, and use them. The other interesting thing that we did is the concept of data vaults. A lot of banks are generally nervous with the fact that we are a cloud-based multi-tenant platform, right? So we have 3, 4, how many different banks on our platform, and each of them have their consumers' data. So what we do is when a consumer gets registered to the Quisk platform, we collect some data for KYC and AML purposes. And rightfully so, banks have a concern. Since you guys are multi-tenant, how do you make sure that you protect the privacy of my consumers, right? So what we did is we made sure that there is clear distinction between what constitutes a processing/transactional data and what constitutes informational data or whatever bank deems as privacy data. And what we did is for that portion of data that has no bearing on our transaction processing, what we did is we took the encryption key from the FI that we partner with, a bank or any other financial institution, and we encrypt their privacy data using their encryption keys. So in spite of our best intentions, if we were to wrongly serve the data to any other entity, that data would be meaningless. And also it prevents any human users, for example, my DBA who have access to production database, from mistakenly seeing any of the privacy data that consumers can have. So this is something that worked well with the banks, and it helped really reduce the fears around data privacy that they had. So that's something that I would strongly recommend. One of the necessary evil that we had to do, kind of learned the hard way, is this elaborate concept of bookkeeping. So we started off with a single logical transactional store, and we were able to derive many different reports that banks asked based on that transactional data. But only later have we realized that a lot of banks are very, very particular about how the data is stored, not just how the data is served. And so we came up with this elaborate concept. I almost got my second master's in accounting. Came up with this concept of double entry ledgers for various type of transactions. And it will be better to know those requirements upfront if you are designing your data models. And the other thing that is helping us is to create what we call as data APIs. Obviously, you start off with services API that do a specific task, but different banks have different requirements on processing, reporting, and it'll be too hard to satisfy so many of these permutations and combinations. So what we did is we are serving up the data in a raw format to our bank customers. Of course, there are some processed data, but predominantly we want to serve it as raw as possible so banks can manipulate them, consume them in any which way that is to their satisfaction. So having all these requirements upfront as you think about your data models and data stores will help a long way from preventing you to retrofit. One other question that I constantly keep getting asked is, SQL versus NoSQL databases. The standard textbook answer is obvious. You use NoSQL whenever there is unstructured data, classical example being social media data with images and all that stuff. In our case, and I think it is true in a lot of fintech companies, is it need not be either or. Each of them have their own place. In our case, the account data and transactional data is very structured, and we use Oracle for that. And we have also unstructured data, especially when we do real-time risk assessment of the transactions that are coming through our system. And for some of the authentication capabilities and some of the distributed caching, we use Couchbase. Again, you could use any NoSQL database, and I think that goes a long way, especially for transient data, in increasing your performance and reducing the amount of code that you need to write versus if you have done everything in a relational store. And just slightly switching gears on the topic of performance, it's obvious that every payment platform needs to reduce latency and increase throughput. One of the things, of course, we have employed several techniques, but one of the things that really helped is when we have these outbound integrations with our partners, we introduce the concept of circuit breakers. Again, fintech companies don't stand in silos. You always have partners that you communicate with. We partner with core banking systems and SMS providers. What we did was, it's very easy to cook up a simple health check monitor that would check if a partner site is up or down, and based on that knowledge that you have, you can fail fast. Any subsequent requests that come to that partner, depending on the use case, either you can fail fast right away, or if that is something that can be processed offline, and we have some of those use cases where we store and reprocess when we automatically detect if the server is back up. And the last item is on merchant POS integrations. This has been the toughest nut for us to crack. If you are not in this, I really envy you. And if you have a business problem to integrate with merchant POS networks, the best thing would be to partner with ever-growing number of MPOS startups or MPOS companies. The reason why it was very, very tough for us is because the POS systems are closed loop, so development is tough, and distribution is also very tough. So if you need to have your application sit on registers in front of merchants, you're much better off going with the MPOS that has a similar kind of Apple App Store distribution model. So again, high level, some of the key things that I thought would be beneficial for you to reduce the time and effort that you would have to expend if you encounter into the same problems.
Okay, we have a couple minutes left, so let's get some questions. So we've seen a few blockchain presentations today. Since you mentioned ledgers, do you currently use or have plans to use blockchain?
Yeah, so I'm personally a big fan of blockchain. We are in the early stages of evaluating blockchain for our cross-border remittances use case.
Okay. What security and versioning schemes do you use for your REST APIs?
So my belief is that there are multiple ways of versioning REST APIs. There's really no much difference between them, except that you definitely need to version your APIs. We put a version number in the URL. There are other techniques. And on the security side, we use digital signatures and a hash of message payload in our partner APIs. And as you have seen in the public APIs, we use token-based security schemes.
Okay, so this is the last question, very interesting. Can you name one thing you would do differently in terms of platform technology?
Yeah, one of the things that we would do differently is the way we built our admin portal, the administration portal. Because we cater to different audiences, we try to build one Uber portal and try to, based on the roles and privileges, try to serve up different information, different data. And that is something that I would strongly discourage. So if you have different portals serving to different audiences, you are better off building these individual portals instead of creating one Uber one.